So, like David said, he's laid the groundwork. You've learned a lot about sort of all the bits and pieces of math objects and how PGML works in general. And now I'm going to take all those pieces and put them together into some more complicated problems. But before we do that, I thought it'd be a good little exercise to talk about the different modes that WeBWorK offers, right? So when we say something is interpreted in Perl mode, it's getting interpreted directly by Perl. And the Perl interpretation can happen before something is promoted to a math object. So obviously everything in a WeBWorK problem is written in Perl, so I could have highlighted everything. But specifically in this context, this Indiana value for pi, which if you don't know, the Indiana legislature in 1897 wanted to change pi to 3.2. So that's my Indiana pi. You can evaluate it directly using the Perl cosine function and get some value. You could put that value inside of a math object and then call compute on it to promote it to a math object. Or better yet, take a string and have math objects interpret that string. So this cosine of I pi here is not highlighted. It's not being interpreted by Perl because it's a string. It's a Perl string to begin with that math object interprets. The distinction being that the line above it that is highlighted, this cosine of I pi, is being interpreted by Perl, and you're getting a numerical scalar value out of that. And then it's being promoted to a math object using the compute command. Okay, so another way that Perl interpretation commonly happens is inside of a WeBWorK question. You might want to execute some Perl code, and in PGML, you use the bracket at symbol rather syntax to do that. And I've done a little cheat. I've used, instead of using good PGML syntax here, I've used the old style answer checker by constructing an answer rule. That's a Perl command. And then also calling the answer comparison method and this capital ANS here that records the value in the gradebook and does all the harvesting of answers from the HTML web page and so forth. Okay, so that's what we mean when we're talking about something being interpreted by Perl. Some things are controlled by the context, right? So once you set a context, like the numeric context, then any math object you create in that context will be something that's controlled by the context. And the context is going to have control over answer checking, so it's going to have control over the domain of function evaluation and so forth. Things like that, all the context flags you've seen so far. And down here I've highlighted, yes, this $C is a math object still, which we're calling a method, a comparison method that compares the student answer to the correct answer. And it's just one of the methods that's defined on any math object. So you can control things more locally. Instead of doing them globally via the context, you can control them more locally within each math object. So for instance, later on we'll see that you can set numerical tolerances or domains for individual math object formulas, things like that. Okay, and math objects, as I mentioned, have methods defined on them. All of them have a string command, a comparison command, the tech command. Formulas have things like eval and reduce, and yeah, so there are lots of methods defined on these math objects that make them much more useful than traditional Perl objects. right? So this Perl object right here, the $A, that does not have an answer comparison method called on it. So if we had down here replaced this $C with $A, we'd get all sorts of errors because the comp method is not defined on $A. Okay, then PGML interpreted is basically anything between a begin PGML and end PGML text command. This also goes for the begin PGML solution and the PGML hint environments as well. You've seen a lot of PGML, and then to drop into math mode, you can use the square bracket single tick or the square bracket double tick, and then everything in between the matching brackets there is going to be interpreted as a text string. Okay, so basically everything between the bracket tick is going to be interpreted by teck. And then one of the necessary evils of PGML is actually explicitly doing the variable substitutions. So you have to, if you have a Perl variable or a math object and you want to get its value printed, you need to enclose it in these square brackets to explicitly say, hey, substitute the value here. The square brackets are not needed in the answer checking. And here I provide, on this slide, I provided a little bit of translation between the new style PGML stuff that we've been teaching you and the older style stuff, right? So for the text blocks, the begin PGML is replacing this context text strings begin text command. And similarly, with the end text, you want to change back to normal strings afterwards so that your answer checkers don't get messed up by text formulas that aren't supposed to be there. Text emphasis, you've seen that. Paragraph formatting is very easy in the markdown PGML, but with the markup old style, you have to explicitly say, break a line or create a new paragraph, things like that. In PGML, the markdown, you can start lists very easily, whereas in the old style, you got a lot of markup there. This one is a good distinction. So the bracket backticks in PGML are replacing the literal teck commands / parentheses for math mode, and similarly for the display style mode, we're replacing that. And for display style centered on a new line, you need to actually explicitly center things and put them on a new line using the arrows that push things towards the center in PGML, whereas in the old style, you just use the teck command / square bracket. In the new style, you actually have to explicitly substitute these values, whereas in the old style, that was done for you automatically in the different modes. And in PGML, to get Perl code to execute, use the \@ whereas you use the / curly brace in the old style. And if you have an answer defined, then in PGML, the answer blank is short for this answer rule command being executed in Perl. And you can pair that up with a math object answer, which would be the same as creating an answer rule, going out of the text mode, ending the text, and then actually comparing the answer and recording the answer. Or more succinctly, you could replace it by this one line bit, which is very uncommon. And with the variable substitutions in PGML, this one's going to get me a lot. because it's something new that I'm not used to thinking about, you actually have to explicitly do these substitutions. So, for instance, if we have a few objects like a formula and a table and some PGML string and say another table that has some old-style math mode in it. So you got 4 different types of objects. They're going to require different types of substitutions. So the ordinary math object just requires an escape substitution. With a direct substitution, you want the HTML formatting or the text formatting for the table to come through in the right way, and that requires a different type of substitution, hence the 1 star. And if you got PGML in the thing that you're substituting, you want to use 2 stars. And if you've got sort of old-style stuff with math mode thrown in, then you need the substitution with the 3 stars so that the math here will actually get processed and done nicely. Okay, so you're familiar with the random command, and the non-zero random command is a good one not to forget when you need it. List random, you can have varying types of scalars in that list, and it'll just choose one of the 3 from this list. Some Perl recipes that I find myself using a lot are if-then statements and do something until some condition is true. So if I wanted a particular random value for B that happened to be not equal to the value for A, I would use this do until command. If-then syntax is pretty straightforward. You put your Boolean test right here, and the then stuff is the code in between the curly braces. So you can have multiple lines of Perl code in between these curly braces. You can have if-then, else-if, else types of statements. The else-if, for whatever reason, lost one of its E's in Perl. That's just a quirk of Perl, I guess. And of course, you can have else statements at the very end. So if A is 1, then set B to 4, else. Otherwise, if A is 2, set B equal to 5. And finally, if neither of those 2 conditions are true, set B equal to 6. You can take your Boolean statements, your Boolean tests using the double equals or inequalities, things like that. You can take your Boolean tests and use logical and logical or operations on them. For strings, things are a little bit different. You're not going to compare strings using equality like this. This is for numbers, but instead you use the EQ operator for strings. If you have a Perl array, I like to think that you pull scalars out of that Perl array using the $sign notation. So $1 is going to be the entry in the array at A with index 1, so that'll be the element 11. If you want the length of an array, I advise you to use scalar applied to that array. If you want 1 minus the length, since arrays are 0 indexed, you might use this quite often. You can use this $number A construction, which is shorthand for 1 minus the number of elements in A. Earlier on, somebody had a question about how to sum up things in an array. One way to do that would be to use a for loop that goes through all the indices in that array. So what we've done is we're naming a variable index that goes through the array 0 through n minus 1. Okay, so this is an explicit construction of an unnamed array from 0 to n minus 1, where n is the length of A. And then for each entry in the array, we're going to take the previous value of the sum, and add the current entry in the array. Okay, so you can reference things in arrays by indices. You could also reference elements in arrays. So you could take your array at A, put parentheses around it, and select elements from it in this for loop. And say you wanted to find the sum of the squares. You could take each element and square it. And this plus equals construction is just short for take the previous value and add whatever. Some gotchas are, of course, double star is exponentiation, and the caret or hat symbol is not in Perl. The hat will work just fine within a math object formula. So if you are calling a constructor like formula double quotes x squared, you can use the hat in that because you've quoted it and are having it interpreted by math objects. Another common construction I'll use is the join operator, which will allow me to put things in between, character strings in between elements of an array and create a string as the result. So this join command would produce a string that looked like 10:11:12. The single quotes in Perl, they do not allow substitution of variables, so we would get a literal $AX there, whereas the double quotes, which I advise using pretty much all the time when you're starting, will allow that variable substitution in Perl. And strings can be concatenated, so if you have a string cat and a string dog, the string concatenation operator in Perl is period, and you would get cat dog as the result of no space in between. If you wanted a space in between, you'd have to literally put a space after the T in cat or before the D in dog. Okay, so now to some questions. So multiple choice questions are not my favorite in WeBWorK. I think there are higher level questions that we can ask using the awesome answer checkers that David and others have written. But here's an example of a multiple choice question. It's got a little bit of math being typeset here. Obviously, I don't really want R2D2 to be the person who authored math objects. Okay, so what's going on here under the hood is we're loading an old macro called pgChoice macros. It provides multiple choice object constructors, and once you have filled that object with some questions and answers, you can call these methods printQ and printA, which will print the question and print the answers. And to get the proper substitutions in PGML, since we've got some math in this multiple choice object, we're going to use the triple star variable substitution operator. And with multiple choice questions, you probably don't want to give students feedback on which parts of their question are correct or not until they've actually answered it fully correctly. And you can even use a custom grader, in this case the standard problem grader. And so down here on my slides, I'll have links to various types of documentation. The subject area templates, as David pointed out earlier, they have PGML examples right in the problem library that you can go to. So that's always a good place to go. The problem technique section of the wiki also has a lot of good stuff. It's all in the old style pre-PGML stuff, but you now know how to translate from the old style to the new style PGML. And then, of course, there's the pod or plain old documentation for macros. Okay, so there are links to those resources right at the bottom of these slides, and I encourage you to use them. So let's dig into the actual problem source and take a look. Okay, so I've got some slide stuff here which you can remove. At the beginning of this problem, we are installing a custom grader. called the standard problem grader, and that's an all or nothing problem grader. So students have to get all the questions correct in order to get any credit on this problem. Then you can see that we've chosen a context, and we're going to interpret things as text strings in that context. And between the context text strings and context normal strings, we're going to construct our multiple choice object, add a question, add a correct answer. We're going to add some extra incorrect answers. We can also specify that some answers should be at the end of the list, and we could have taken some entries from either the correct answer or the extra answers and put them down in this make last command. They would not get duplicated, but they would be forced toward the end of the list by doing that. Okay, and then in the PGML, we're going to drop into Perl mode right here and print the results of that Perl mode using the triple star substitution. So we are printing the questions, we are printing the answers, and then I'm using this less common construction for answer checking. I could have taken this answer checker right here and put it down below the end PGML line, and that would have been probably more standard. Okay, and in the solution, there is a method called correctAnse, which you can use to print the string, which is the correct answer. Okay, so then there are a few more things like this. So multiple choice questions with checkboxes. I'm just going to jump right to the source and view the problem source. So we're using the same macro as before. Pretty much everything is the same, except in this constructor we're using a new checkbox multiple choice instead of just a new multiple choice. And there can be multiple correct answers, obviously. Okay, and basically everything else is the same until down here we're using an old style answer checker named checkbox comparison to do the answer checking. Okay, you can also do drop-downs, pop-ups, as what they're called in WeBWorK. Elvis is reincarnated as John Travis, and the best programmer in the world is David Cervone. So let's make sure that we got those correct. Yes, okay. This is a newer macro written by David Cervone, the parser pop-up macro, and the constructor for pop-ups is basically a list of choices followed by a correct answer string. To generate the pop-up menu, you can use that command. To do the answer checking, you can use that command. Of course, those are, in some sense, a little obsolete now that math objects are on the, PGML is on the scene. So let's take a look at the problem source and see how everything is done. Okay, so you can see the pop-ups are constructed here using this pop-up command, a list of possible correct answers, and then this answer string that is the correct answer has to be verbatim the same as this, otherwise you'll throw an error. And we constructed a second pop-up using the new PGML answer checkers. You can just do the answer blank construction and put the pop-up object in there. Or using the old style answer checkers, we could do drop down into Perl mode and print the pop-up menu, and then later on we will check the answer explicitly. Okay, and there's a way to harvest the correct answers from the pop-up and display them in the solution as well using this correctAnse method. Now we're going to jump back to some older style pop-ups. These were probably written by Mike Gage around the advent of WeBWorK. Maybe it was Arnie Pizer, I don't know. So here we're using the old PG choice macros again, and there's an explicit constructor. You populate a list of questions and answers. You choose some number of things from that list to be displayed to the student. Then you print them, and you check the answer, and so on and so forth. And we'll talk about the custom grader that's installed in this problem as well. Okay, so let's look at the source and see how this multiple pop-up question is done. Okay, so we're loading this PG graders and PG choice macros macro. And the construction of the true-false objects is, or true-false object is, well, first we create a new select list, and that might seem confusing. Well, the select list is what these things were originally called, right? You could have a true-false question where there's just an answer box and students have to manually type in T or F or true or false. I find that students screw up a lot less when you give them these drop-down menus. So that's what we're doing here. We're using these pop-up lists by this select list command, and then telling the true-false object to actually print using those pop-up lists. And then we're going to populate this the options for the true-false object. Okay, so you wouldn't have to do a true-false question here, right? I just chose that. You could have done something must, may, or cannot happen, right? You could have 3 options here instead. Then we're going to populate that true-false object with some questions and answers, Q&A. I think it's a pretty straightforward format. As you can see, we've got some old-style math typesetting going on here. And because of that, we're going to make sure that things are interpreted correctly using the text strings command up above. And as mentioned before, we're going to choose some number of things to display to the student. We will display them to the student. And then the answer checking, I thought I'd get a little bit, have a little fun with this. So the standard answer checking would just be a string comparison on this list of correct answers in the true-false object. Okay, so this is a very old answer checker, but that doesn't mean it's bad. It just means it's, it survived a long time. So that's technically all we would need. If we ask the question with only this line, then we'd be using what's called the average problem grader, and students would get, 1/6 of a point for each part they get correct. Now, suppose that you don't want that. You want to group them. You want to require the students to get a certain number of questions correct before they get some credit. So you can use a custom grader by installing that custom grader and then giving it some options, telling it that there are, a total of 6 questions, and that after 2 questions are correct, or 4 questions are correct, or 6 questions are correct, we're going to give these percentages of credit. Okay, and then we'll explicitly give the students a message about how the answer grading is done, so they don't get frustrated when they answer one thing correctly and it didn't give them a 1/6 of a point. You can see here that we've constructed a longer string by concatenating several strings together using the concatenation operator. Okay, essay questions are relatively new in the past 2 or 3 years, written by Jeff Gala. And I like to pair them with true or false type of questions where students have to commit to a certain answer and then explain the answer. So there's a special macro for that, the essay macros. And this is one of the most non-standard answer checkers you'll see. Obviously, the stuff that students type in for explaining their reasoning has to be graded manually. And so it uses this custom answer checker called SAComp, which really doesn't take any arguments in because, well, there is no one correct essay answer, and you wouldn't want to have to add it. Even if there was, you wouldn't want to have to add it to the context as a string and do all that messy stuff. Okay, I'm choosing to use the all or nothing problem grader so that students don't get half credit just for choosing the right option here. And I will withhold feedback from them so they don't know which of their true or false options they chose is actually correct. So let's look at the source for that problem. Okay, pretty standard. We withhold feedback and install the problem grader. Created a pop-up and displayed the pop-up. And then in order to display the essay box, we used this essay box method or subroutine in Perl, which is why we've got this attached bracket construction here. And these parameters in the essay box mean we want it to have 8 rows and 60 characters wide. And then the answer checker for the essay is this SAComp method. It's kind of a dummy answer checker in some sense. It doesn't really do something. You have to go in and do it manually later. Okay, and a basic graph example. So this illustrates many of the functions you'll commonly use in graphs, things like making lines or arrows or points with labels, labeling the axes and having functions that are graphed. Okay, and there are links to some documentation here. Let's take a look at the actual source code. In some sense, it's sort of self-explanatory. We're using this graph macros macro to do all this. And then in order to construct the graph, I'm going to first define something called the size of the graph, the number of pixels, which I'll use throughout the problem. We have to create the graph canvas and essentially add a bunch of things to it. So this init graph command constructs the canvas and says, make some axes that go through 0, 0, make it a 400 by 400 size graph. You can explicitly specify where you want horizontal and vertical grid lines if you want. There's also a grid option, which you'll see in the breakout. We can explicitly attach labels to the axes, like the X and the Y. You have to specify a point where they will go, a color, and then a horizontal position, left, center, or right, and then a vertical position, top, bottom, or middle. I use a for loop to label these axes. So go through values of I from 1 to 3, and at point I0, label it with I, and do the same sort of thing for the y-axis with a little bit of offset from the y-axis so that the labels don't actually land on the y-axis. You can take a math object formula and use it in this add functions command to add a function to the graph canvas. And of course, this is pretty self-explanatory: domain, color, weight. The lines that you want to plot on the graph are using a cursor method. So you literally have to move the cursor to a point and then draw a line to some other point, specifying the color and thickness of the line. And if you do not move the cursor anymore, then at that current cursor position 2, 4, you could draw another line to the point 4, 0. You can also add labels. So we changed the cursor position back to the origin here and drew an arrow that's red with thickness 2. We can add a point or a stamp, closed circle, to the graph. as well as a label LB. And the syntax for this is kind of old and a little bit clunky. It could be smoother, but it is what it is, and it works. And, you get used to it. You copy, paste, and modify. It's not so bad. Then to actually insert that graph object into the display, we're going to use the insert graph command, which will make a PNG or GIF file, which then gets displayed using the image command. Okay, so this is all in Perl mode, and we are centering the output. And over here, I've got a couple spaces at the end of this line, so that we'll get an actual new line, and this figure caption will appear below the image. Okay, and here's an example of how to include a static picture or image file. And it's pretty straightforward. You want to use the image command, and you tell it the name of the file you want to plot. You give it a few parameters. The width and the height are numbers of pixels for the image displayed in HTML mode. And in tech mode, you also want to specify what fraction of 1,000 the displayed image should be. So by setting this to 900, we're essentially saying take up 90% of the column width in order to display this image. If you're displaying several images side by side, you'd probably want to change each image to have text size around 400 or 450, so that two images could fit side by side. Okay, a little bit on images. You can use GIF or PNG format, not JPEG, because that's proprietary, and WeBWorK has wanted to avoid any sort of issues. Of course, do not break copyright when you post images, so it should be your own work or something that's freely available. Now, the way that image files should get assembled is to put, well, essentially to bundle your PG file and your image file together in one directory. Okay, so if you had a PG file named file1 and a couple picture files, you would want to create a new directory called file1, the same name as the root of the PG file. Okay, so to create that directory, put all of the files in that directory, and that way the library browser will be very smart about handling this PG file and its associated images. Okay, so how can this be done? It can be done using the file manager. So let's actually fire up the file manager and give an example of this. So I'll go into the Workshop 3 AM folder, and I think this particular slide was called 26 Basic Static Image. Okay, so if I wanted to take this PG file and add some images to it, the appropriate thing to do would be to create a new folder by the same name. So that's named 26 Static Image Exercise. 26 Static Image Exercise. Okay, so create a new folder by that same name. And then, notice I've got the folder there. I've got the PG file by the same name. So I'm going to move that PG file into the folder. The rename command is essentially providing you access to the Linux move command. And I want to move it into this folder named 26-static image exercise. Okay, so scrolling down, now we see that there's just one thing by that name, and if we double-click to enter that folder, we'll see that the PG file is in that folder. And if I wanted to, I can then upload. I can choose some sort of PNG file. Oh, I don't have a good file. Oh, I do. I guess I do. I'll upload. Oops, that's a JPEG. It's not going to like JPEGs. I could upload a PNG file to the same directory and then go in and edit the PG file and actually call that PG file up and provide the appropriate width and height for that PNG file. So how would I get the appropriate width and height? Well, let's see. In Windows, I open the Explorer and navigate to this PNG file. If I just hover, it'll tell me the dimensions are 499 by 143, and those are the width and height of the image. So I could go back and modify. Oops, got that in the wrong spot. Was it 499 and 103? And then I could save my changes, and all would be hunky-dory.